was thinking about doing the thing where I jump out at you again, but I figured twice in a row is too many times. Oh, my goodness. Look at that. So we're going to take a look at the review problems for the midpoint formula and the distance formula. Yeah. All right. And then hopefully, maybe not in this video, but another video, we'll talk about transformations. So we're going to find the coordinates of the midpoint of n, m, n with, oh good, I love zeros, with m at -2, 6 and n at 8, 0. All right, so distance formula and midpoint formula get all bobbled up in my head. Now midpoint formula is when we're trying to find the average and the distance of the two of x and y. And distance formula is when we want to find a Pythagorean theorem problem. Okay, I got it. So midpoint formula, we're going to be doing x1 plus x2, and obviously you can reverse that, it doesn't matter, it's addition. Divided by 2, comma, y2, fine, y2 minus plus y1 over 2. Been doing a lot of finding linear equations today. All right, so let's go to it. So we have -2 plus 8 over 2, comma, 6 plus 0 over 2. All right, so -2 plus 8 is 6. So we get 6 over 2. 6 over 2 is 3. And does that make sense logically? Yeah, because 3 is halfway in between -2 and 8. All right. 6 plus 7, well, that's another 3. All right, and 3 is halfway in between 6 and 0. Oh, that's not too bad. K is the midpoint of HL, and we need to find the coordinates of L, and K is in the middle. All right, so let's draw a little line segment. It doesn't matter how accurate it is, we just need a line segment to help us work. So we have 1, comma, -7, and that is H. Over here at L, we don't know what L is, so I'm just going to give myself some room to put an answer in. And then we have a midpoint, K, the most noble of all the letters, and it has coordinates of 9, 3. All right, so twice 9, so twice 9 is 18, right? And so this number plus this number has to equal 18, because then when we find the average, we divide it by 2, and that will get 9. So what 1 plus something is 18? Well, that has to be 17. All right. Same logic here. -7 to 3. And then, okay, so 3 times 2 is 6. So -7 plus something has to be 6. So -7 plus, oh geez, it would be 7 to get us to 0. All right, and what do we need to get to 6, right? So then 6 plus 7 is 13. 13, so 13 plus -7 is 6. 6 divided by 2 is 3. All right, we found it. The coordinates of the vertices of a triangle ABC are, oh, let's just draw it. And so I'm not going to be to scale. So we'll call this A, call this B, call this C. All right, so A is at 2, 5, B is at 6, -1, and C is at -4, -2. Oh, that's not too bad of a scaling, if I do say so myself. All right, find the perimeter to the nearest tenth. Oh my goodness. Well, to find the perimeter, I need to know the distance of every line. All 3 of them. Of course, we're going to have to use the Pythagorean theorem twice for the distance formula. Oh, 3 times. I teach math. 3 times. All right. So the distance formula says that the distance is equal to the square root of the difference in the x values squared plus the distance of the y values squared. All right, so let's do AB. So we're going to go 6 minus 2 squared plus -2 minus 5. All right, squared. So 6 minus 2 is 4. 4 squared is 16. So we get 16 plus negative 2 plus minus 5 is negative 7. Negative 7 squared is 49. So 16 plus 49 is 65. So we need to find the square root of 65. All right, that's not too bad. 65 squirt. So that is equal to 8.1. This is the nearest tenth. All right. So I'm going to use a different color here. I'm tired of the hot pink. I don't even like hot pink. Red is much better. Yeah. All right. So same idea here. So we have the square root of 6 minus negative 4, and that's going to be squared, plus negative 1 minus negative 2 squared. Well, okay, so 6 minus negative 4 is 10. 10 squared is 100. So we get 100 plus, and we have something that is not legible whatsoever. Way to go, Mr. Frampton. So we have 1 minus negative 2. 1 minus negative 2 is 1. 1 squared is 1. So this distance is the square root of 1 and 1. All right, I don't know that off the top of my head. I'm guessing it's just a teensy bigger than 10. Squirt. Oh, and it is. Well, and if it's to the nearest tenth, it is 10. All right, finally, the last one. We have, scoot over here. Now you get to see me on the other side of the screen. So we have, that's going to be my second value. So we have 2 minus negative 4. I'm going to square that. And yes, we're taking the square root of the whole thing. Plus, well, we have 5 minus negative 2 squared. So 2 minus negative 4 is 6. 6 squared is 36. All right, that's good. 5 minus negative 2 is 7. 7 squared is 49. All right, so we'll have to square root it. So 36 plus 49 is going to be 585. We have to take the square root of it. So 85 squirt is 9.2. So we have 9.2 here. All right. So let's add them together. So we have 9.2 plus 10 plus 8.1 equals, so we get a grand total of 27.3, and that's it. Ooh, that was longer than I really wanted to spend on it, but we got there in the end, right? So using the distance formula to the nearest tenth, again, I just did it 3 times. Got it right this time, 3 whole times. I have to do it again. All right, so x value, so we have negative 3 minus 6 squared plus negative 4 minus 5 squared, and we're taking the square root of this. All right, so we have, hey, welcome. So we have negative 9 squared, which is 81. We're going to take the square root of that. And then we have, oh, another 9, right? Oh, that's cool. So 9 squared is 81. So now 81 plus 81 is 162. And so we have to take the square root of 162. So 162, we're going to squirt that. And so the distance between point S and point E is going to be approximately 12.7 units long. Whew, that was a lot of work. I'm tired. I'm going to go take a nap. It'll work better if I was already on there. I'll take my nap.